anything later on. All right, how about now? Oh, God. All right, this is going to be slightly nonsensical, but you know what? We are going to deal with it. Cool. Get this out of there. Get this out of here. No, stop that. Stop that. Okay. No, that's not what I want. No. No, I don't want to end a meeting. Why are you like this, Zoom? Just let me do the things. Oh my God, does it really have to be full screened? I'm going to fight it. All right. This is nonsensical, but it's what we've got. Oh, geez. Okay, people on Zoom, can you see the slides? Answer me. Yes, thank you. Thank you. Okay, sorry about the massive delay there. Today is a day where I'm especially going to have to be showing a lot of video. And so I was hoping for some reason that these computers might have mics in them and I'd be able to just use the computer in the classroom. But why would that be the case, right? Why would it be so easy as to have that be how it works? Anyway, today we're talking rules. Before we talk rules in too much detail, oh, you see the presenter view. Why are you? Oh, it's because this, huh? It doesn't matter. I have no notes. Present. I don't want to do presenter view. How do I turn off? There we go. Presenter view. Please work. Please just do the thing. No, really. You don't want to click buttons now. What the heck? Okay. Just click. Oh my God. I'm gonna physically fight this computer. Oh, I should have just stuck with what I was doing. No. Oh my God. It literally won't let me click from current slide anymore. Okay, we are gonna close and what? We're just gonna close it. Okay. Yeah. Uh-huh. Oh, is it because it wasn't saved locally? Oh my God. Jeez Louise. Okay, that's good. Go back over here. Just gonna do the full screen. And then get this out of my way. From beginning, please click, please click. Oh my God. Do I have to use presenter view? No, it's just not even clicking anymore. Start slideshow, please, Lord, start the slideshow. Okay, this I've struggled with for literally 6 minutes. We're just gonna present from here. Whatever, I don't care anymore. I'm just gonna do this. We'll live, all right? No animations, who cares? Okay, so there's an office hour today from 12 to 1 p.m. Then evening, I guess I wrote that twice, office hours help session from 5:15 to 8 p.m. Homework 2 will be due this Monday. There is the 23-hour grace period after that. Just as a heads up, yes, you still get that. You'll get that every time. Then there's going to be a practice quiz today. Quiz 2 will be next Friday. This means that there's going to be quite a bit of a sort of less topics. There'll be fewer topics on this quiz, but that's fine. It's still the same number of questions roughly. It's just so funny that it just literally won't let me present, like literally at all. It will not let me click on these slides to present them. Oh man, this is so annoying. Whatever. Okay, so a quick review on how game engines work, because I think that some students had a bit of misunderstanding for certain topics as they were coming up. Particularly for MCTS, this can get a little bit weird. So the basic way that game engines work, right, is that we have a series of objects, a series of game objects. In Unity, they're literally called game objects. And the way that it works is every single update tick, which is every single frame. So if we're talking about 60 frames per second, that's one every 1/60th of a second, right? We are going to be calling an update function on every single object. Now, objects can also call each other, right? That's completely possible. They can call particular functions within each other. But in general, we're going to go from the beginning of an update function for one object all the way to the end. The ordering, because there has to be an ordering, right? Unless we're doing like a multi-threading thing, the ordering is always going to be somewhat arbitrary, going from one object until it is completely done. You can affect the ordering. So like in Unity, for example, it's super hacky, but literally the order in which objects are listed in the scene is the order in which their update functions will be called. So for example, you can change it like that. This is just important because what we're talking about is a little bit of computation, right, happening every single tick. This is not the case that we're going to, for example, if we were running MCTS live, run an entire MCTS approach on one update tick. Rather, we would store where we are and do a rollout from there, or maybe a few rollouts, depending on how much time we have, and then use that to keep on moving forward at that point. Cool? Okay, cool, some nods. Okay, this was meant to be like a question. God, this is so frustrating. Sorry, folks. I keep complaining, but this is just really annoying that this is happening. You know what? You know what? I'm going to be on 2 screens anyway. We can do it this way. I just realized a very trivial thing I can do to fix this, which is that I will show on my screen until I need to be on the other screen. Here we go. Get out of here. Oh my God. This is so funny. And by that, I mean deeply annoying. Okay. Is it not connecting now? Oh my God. Why is it like this? There it goes. Ha! Look at that. Totally working, right? People on chat. I could try F5, but literally nothing was working. I was clicking every possible button. Can you all see this? It's zoomed in now. I mean, it should be zoomed in now. It's kind of cut off. What the heck? It may be slightly cut off on the right. What? What? This literally doesn't make any sense. Okay, fine. I won't resist the whims of fate anymore. Clearly, I'm just doomed.
Professor, I think you're muted.
Muted. Unmute. How annoying. I can hear you now. It wasn't unmute. It was that it no longer connected me on one screen. Anyway, has anybody seen this before? Block World? Understandable. This is a historical environment. It was originally created by some of the earliest roboticists. And the idea was that they could study basically how to make use of chains of rules to be able to accomplish tasks. So for example, we could have a rule like pick up a block at location XY. There could be a precondition for that rule to say that we have to have no block above it, right? If we want to pick it up, and that the block has to actually exist at that location, right? In comparison, we could have move block, which is if we're holding a block currently, then we can move a block to a particular location as long as there's not already another block there and there's not a block above it. And then drop block, which does what it says on the tin, right? If you're holding a block, drop that block at the current position. So then you can have things like facts. So facts or percepts are a very common way of representing what is true in the world, right? You can just think of these as variables, right? Or values. So in this case, we have block 1, which is at position 5.3, block 2, position 5.2, etc. Right? Now, the basic notion here is that what we can do is we can have these different rules that have particular conditions, then particular effects. And by stringing together effects that they match conditions, we can accomplish pretty complex tasks. Well, you might not think of moving blocks around as a particularly complex task, but this was really exciting in the 90s and the 80s, all right? We didn't have a lot going on at the time. So this kind of thing where we have a whole bunch of rules and the idea is that we're going to have multiple rules firing, this is called a production or a rule system. During the last golden age of AI, this was like the thing. Everybody had just complex production rule systems for trying to do any AI task. This was before the advent, or not the advent, the machine learning existed, it was just really bad. Facts are matched to rules, ifs, using pattern matching, right? And then we're basically going to, if a rule is activated, or a whole bunch of rules are activated, we want to choose an active rule that we actually want to fire, and then that will lead to some change to either the facts or to the world itself. And then we're going to keep repeat this process. So in video games, we might end up with facts like this, right? Like the health of different entities, what they're holding, their weapons, etc. Represented in a number of different ways, right? It's just like a whole bunch of lists, it's like JSON, things like that. And then we have rules. So if Whisker's health is under, say, 15 and Whisker's holding the radio, then Whisker could radio call in help on the radio, right? If Whisker's health is 0 and Whisper's holding the radio, then remove the Whisker holding the radio, add the radios on the ground, and spawn the radio on the ground. So this is what I mean by multiple conditions, right? This is a long logical phrase. And then multiple effects. These are all things that have to happen after that rules fires. Okay? Cool. So production systems in the game industry, well, I gave you some examples there of, get out of here, where I gave you some examples there of places where, just to check, no, so what's happening is it's going to another screen that I can't get to, which is really cool and very helpful. Thank you, PowerPoint. It heard me. Basically what's happening here, right? Oh, wait, I was sharing the wrong thing. I need to share the full screen. Yeah, here we go. So in games industry currently, production systems are primarily used as dialogue or voice lines. Did anybody play Hades? Some hands, okay. Not a whole bunch, surprisingly few. Hades is a really good game. Some people saying in the chat. Let's take a quick look. We don't have a whole bunch of time. It's not even gonna let me copy. That's very funny. Oh, actually, I already have it open. Let's mute and add real quick. I'm gonna have to be muted during the presentation of why? Oh, okay, because I can skip it. No, I don't want to try YouTube Premium. Oh my God. People in the chat, I'm gonna have to be muted for a second. Yeah, Zoom does hate me. Yeah. I'm gonna have to be muted for a second while this video plays. Otherwise, people will hear terrible reverb.
He wouldn't stand a chance against her without all of those upgrades that you've steadily been unlocking for him as you play. It's a pretty solid burn, to be honest. However, if you then on your next run remove all of those upgrades, which almost nobody will ever do by the way, she references that in the next fight.
I sense something different about you, Zagreus. Your old weakness. Ah, the mirror. I thought you said you weren't trying to compete with me.
It's a tiny, tiny detail and one that I can't imagine many players will ever experience.
There, we don't have a lot of time. You can always go back and watch it later yourself. So what's happening there, right, is that we have a dialogue system which is making use of rules. If the player does this, then say this line, right? Does that make sense? But that's not all that's happening. There's actually a whole bunch of complexity stuff. I don't have the time to go through everything here. Obviously, I don't have the time. But at a high level, what's happening here? Are you yelling? What's wrong now? To be worse than usual today, huh? Yeah, well, I had hubris and I thought that it would just work like normal. Anyway, the basic notion of how this works is that we want to turn the environment into facts. Now, the environment doesn't just mean, hey, what's around us, right? It also means what is true about the current state of the game. So what is happening? Yeah, good, I'm hearable. What is currently happening? What did the player just do? What is the current state of various other entities in the game? And then that gets added into a big old agent database, which is basically going to be a set of variables, a set of percepts, a set of facts. They can't see the slides? Oh my God. Like, honestly, I should just give up at this point. How about now, people in the chat? I'm definitely not muted. Yes, I have to be muted on the PC or else we get voice of God. And also there's no mic. Watch this, it doesn't do anything. Nothing has changed. Cool. Jeez, crazy. Anyway, trivial way to do this then would be to write a line of dialogue for each fact. So for example, anytime that the player just went ahead and changed from having all of their stuff on to having all their stuff off, in the Hades example, we're just going to go ahead and have a distinct line of dialogue for that. But that would be a massive amount of work, right? If we did this, we would have to have, for everything that can occur in the game, we would have to have a distinct line of dialogue. And that's wild. That is far too much. That's not possible. Even for giant AAA studios, that's not possible. So let's take a look at a quick example. As foolish as this is for me to try to show you yet another example, unfortunately, this lecture is designed to require that I show you a whole bunch of examples. Now, these examples come from a GDC talk from way back in 2012. This was some tech that was being used by the Half-Life 2 devs in terms of how they structured NPC conversations. This is part of a series where they sort of go through the development process of a particular dialogue system. And I think it's particularly helpful in terms of understanding how dialogue systems like this work. Okay, let's do the fun song and dance again.
A laundry car? There's a laundry nearby. I don't want to alarm anyone. But I see a soda can. Look out, mate! A water sink!
This heater appears to be broken.
Anyone want to see me break this cinder block with me head? Anyone? A shoe. Someone's gonna fucking miss this.
Danger. Flammable materials. Look at me, that does sound dangerous.
Look! Chinese food!
This is not a Half-Life mod. This is a developmental environment that was made by the creators of Half-Life. You should have been able to hear me say that, but I guess you weren't able to hear me say that. Okay, so if I go back to here, can they now see this? Okay, phenomenal. Let's hope that that continues. Jeez Louise. Okay, so what's going on here, right, is that for each character, basically every 10 seconds, we're going to find every object in a sort of vision code, some sense of like, what can that agent actually see? Just send out a whole bunch of raycasts in a cone shape, see what they can see. Pick one of those objects and then randomly select something to say. Now you can see in that video, right, that the robot seemed not particularly coherent. It was just sort of like looking around and saying things and seeing things, just like a toddler yelling about seeing, anything in front of them, right? Which is not necessarily what we want. Maybe for a certain kind of character, that would be good. That would be a good AI. It would help convey the character. But for something like this, that's not exactly what we're going for. So, okay, first participation question, which is, how could we extend this framework to allow for agents to have a conversation? Go ahead and throw that there, or not. It did say it was copying, but it lied to me. There we go. Oh my gosh. And I will also throw that into here. Absolutely horrific. So basic question, in case you can't read on your own, which is understandable. How could we extend this framework to allow for agents to have a conversation? So instead of just seeing a thing, saying a thing, right? How can we get them to actually talk to each other? Yes? Between the agents, different AI agents for now. If I could show you more of the video, I could show you back and forths, right, between the different entities, but we don't have the time. Okay, I'm just going to open that up this side. I'm not going to try to jump between sharing my screen. That was hubris. Why would I think that would ever work? Okay. So let's see, we have some options here. You could have a link triggers to other characters. So when one says something about a sign, the other one can chime in with their own pool of responses that would be appropriate for that specific trigger. So you could do something like this, but we're gonna need to get a sense. My sanity dwindle, yeah. Ain't that just the way? You could do something like have some link between the different conversations between the different characters, but you'd run into a problem here, which is that you can't necessarily know if we have these characters moving around the space freely, whether two characters will be in range. So if a conversation is dependent on another character being there, then at that point, you just have to write one distinct conversation for every single time you would see something. Every time you would have a conversation triggered, you have to have a distinct conversation written, which is a lot. Nodes in a path network that trigger certain character actions and dialogues, if they are both there. So again, same problem. We can have flags for the agents to respond to each dialogue line that is played by the other AI. So flags is an interesting idea. Let's get back to that in a second. Keep track of what dialogue has been said, heard, and use that to determine what comes next. Also very interesting. We're sort of going to do something like this. Picks from a set of responses, yes, but the implementation details are important here. So we want to do this as simply as possible, right? We want this as simple as possible. And the simplest way to do this is to write extra effects to the world to say, hey, this just happened. This line of dialogue just happened. And then you can use that to as the basis for additional lines of dialogue. So as a sense here, right, we could see a barrel like that robot did in the video, then say the barrel line associated with seeing a barrel and write seen barrel to the world. This is now just a variable that we're going to turn on. This is true now. And then if we see barrel plus seen barrel, again, because what we are having as our input is not just what we can literally see, but it's just what is true, then we can come up with all kinds of different appropriate next things. And it doesn't have to be limited to a set conversation, which I'll give you some examples about in just a second. I think we're actually going to skip this because there's not a lot of time. But all right, we're going to try this. If I have to end up skipping one of the videos at the end, that I think is better than skipping this, because I think this is relatively informative in terms of what is happening. So now we're going to have the two agents talking to each other. I'm just going to do this. Just going to do this every time. Sorry that my pants are apparently on screen. I'm just going to do this like this. We're going to go there. Okay, everybody should be able to see that just fine. I'm going to do the thing where I mute.
Danger. Crane overhead.
Caution, you're an idiot.
It won't be so funny when you get crushed by a bloody crane.
What kind of monster locks a traffic cone in prison?
It's unconscionable.
It doesn't even make sense.
Do you know who sat at this desk?
Who?
The warden.
No.
It's true.
A wooden plank. They were trying to keep something in.
Or out.
Well, it is a prison, mate.
Yes, probably in then. Oh, that's a rather shabby crate.
Oh my god, it's horrible.
Ah, I accidentally looked at it again.
Stop looking at it.
Okay. So then at this point, we have this final thing, which is about what about long-term memory? These are things that like Overwatch, Apex, Valorant do. So not things. Let me say that again. These are not things that these types of games. Does anybody play these types of FPS, like character-based shooters? Yeah, there we go. Hands up. Where they have two characters that will like talk to each other if they happen to be on the same team, right? Or if like one character kills another. So those are all like very local interactions, right? So like if we just have one character that has some vendetta against another character, if they kill them, then they'll say something about that. But that's it, right? It's just what happened just now. But what about long-term memory, which is to say, what if we want to track some notions of like change over like an entire narrative, right? Or whole area. So in that case, instead of writing a Boolean like seen barrel, we could actually have an integer, right? We could count the number of times that something happens. And then use that to say when it's above a certain number or below a certain number, right? Have different things happening. Now, with barrels, that's just an example, right? But this could be things like the number of times, this character sees a horrible monster, right? Or the number of times that like you betray a character or something like that. Could be arbitrary things that we can track like that. Okay, one last example from the funny robots, and then we should be good to go. And I can stop doing this sharing back and forth. And there's still a practice quiz today, so I have to save 8 minutes at the end. Oofa doofa. Okay, just to confirm, Can they see the, okay, good. They can see the YouTube. It's sharing sound. Phenomenal. Well, I'm getting better at this.
I heard they use these barrels to store vast quantities of urine.
I very much doubt that.
Do you doubt it enough to go stick your head inside? Look out! Another urine barrel.
This heater appears to be broken.
We gotta get out of here before we freeze to death.
Another broken heater. The entire system must be down.
This is the type of bottle that I'm afraid might contain a bit of urine.
What is wrong with you?
This prison is a bloody minefield of possibly urine-filled containers. Oh! A leprechaun!
It's a doll. It's just a doll.
Bloody hell. You won't fool me again, leprechaun. Up high!
Yeah!
A lubricant machine. I could use some lubricant.
Breen's private reserve of urine.
Like valve thing. People are unfamiliar. Anyway, so what's happening there, right, is that by having these sort of set variables to track how many times this weird robot has talked about being worried about urine, right, what we're getting here is the setup for a joke. And the setup for the joke, the things that checks to see, hey, can we do this joke yet, is literally just a set of conditions to say, is it the right time? Is this joke gonna land if we make this joke? If this robot had, had this response of like, hey, you're drinking urine for some reason, I don't know, the valve people are weird. If this robot had made that joke, at the very beginning, it wouldn't have made any sense. The conditions being built up over time is what makes that work. Okay, let's jump back to here. So this gets us to Left 4 Dead. Has anybody played Left 4 Dead or Left 4 Dead 2? Okay, some hands. Understandable, it's a slightly older series now, but this was actually in development, this sort of dialogue system, and then it was predominantly made use of in Left 4 Dead 2. So Left 4 Dead 2 is a little bit weird because you have this situation where you have these 4 characters that are sort of the protagonists of the game. The player can choose any one of them, or you can have multiple players playing them. But at any point during the game, the player could swap which of them they had control of. The player could also lose some of them. So some of them could die during a mission, and then they're not there. So you have this like extremely massive branching issue, right? Where you don't know who's going to be present for what conversation. And that means that you have to have a conversation system, which is really dynamic, which can allow for any possible combination of any possible set of people being there. So the way this basically works is a massive amount of dialogue, right? And where a massive amount of dialogue has a whole bunch of different possible conditions to it. So for example, the very top one is a super general piece of dialogue. If Nick, this character Nick, is hit, then they say, ouch. That's it, right? And this is very general because it has very few conditions, right? Because it has very few conditions, this can happen almost any time that Nick is hit. Now, Nick did not reload. Nick's health was not low enough for this one, but Nick was hit and near an ally, and so could instead yell, hey, ow, help. Nick was in fact hit while at a circus and could say, this circus sucks. Nick was hit by a zombie clown and could say, stupid clown. And finally, Nick was hit by a zombie clown at the circus, could say, I hate circus clowns, right? So you get iteratively more and more complex conditions such that we can always try to go for the most complex thing. Whatever is the line of dialogue that has the most conditions that have been, that most conditions flat out, and that is fully satisfied, right? That has passed. This is an important distinction. It is not just the most number of conditions. It is the most number of conditions where all of them are true. That's the one that we want to pick. Cool? And this allows us to sort of fail gracefully, where if like Nick ends up hit by something that we never expected Nick to be hit by, if we never wrote a line of dialogue for Nick being hit by, I don't know, a crane or a car or something like that, Nick can still respond. Cool? I'm not going to show you this final example. You could watch it on your own time. We just do not have the time to watch it. Okay, so some final thoughts on production rule systems. The nice thing is you do not need to specify a response to every possible contingency, right? You can have this sort of notion of increasing complexity, which means that we can always fall back on more and more general things. You can also respond then to novel conditions, situations that the developers never thought about, right? If you've ever seen like somebody doing a speed run or hacking a game where a character still says something that seems appropriate, that's what's happening. There's just enough of a general response that you can actually end up adapting reasonably to novel situations that the designers didn't think about ahead of time. The cons is that this is still really hard to author, right? It's hard to author these systems that are going to fail gracefully. You can always have a very general thing that you can say, that's easy. But having more and more complexity that sort of builds up in a natural way, that's tough. This gets into like sort of the more design problem. There's also a problem of emergence versus over-engineering. So we could do the thing where we write one line of dialogue for every single thing or a conversation for every single thing that could happen. But that's not going to necessarily lead to emergent and interesting things happening, right? Where a character says something in a surprising situation. It's also really hard to debug, right? Because you just saw that screen where you just saw like, okay, if all of these rules could fire, and then we know which one did fire because we've heard it, but trying to figure out, hey, why didn't you pick the other one? That can get really complex, especially with lots of conditions. You can say, okay, now which is the one condition that was at fault here for you not firing? You can also get into repetition, but there's an easy way around that, which is just to say, like, if Nick keeps on being hit by zombie clowns, we can have a secondary thing that picks between them, not just based on how many conditions there are, but also how often we've said that thing. So that way Nick doesn't just say, I hate circus clowns over and over again. Okay. Finally, doing this at runtime can be pretty tricky. While actually figuring out how many rules fire can just be basically an O of 1 lookup time. Actually picking out what's the most specific rule to fire in a particular situation, that can be pretty difficult because we have to search through all the rules, right, that could fire. So depending on the size of your amount of dialogue, like I think that the Bethesda folks just said that their newest game is going to have like 150K lines of dialogue or something like that. Like imagine having to search through every single one of those every single frame, right? That'd be ridiculous. So instead, we often use, speaking of our last lecture, a tree representation, right? Where I don't have the time, unfortunately, to like show you this. Maybe we'll talk about it on Monday. But basically, we're gonna have less individual fact checks by basically building up, see how deep in the tree we can get, where each node is a condition that has to be true or has to have a particular value. Okay, I think that's all the intuition that I'm going to be able to give you for today, because now, final thing, we've got to do a practice quiz. Oh, that didn't copy, did it? There's no way on earth that copied correctly. This is also just my bias against Windows machines. And grab this. Okay, and then will you be kind enough to let me, can I get rid of this? No, oh, what the heck? Oh, that was weird. I'm just gonna try to do this because I don't want you to be able to see the answers. Well, you can kind of see the answers anyway. Oh, yeah. All right, this one's better. At least the answers are smaller there. Let me do this. Can I? Oh my God. Everybody pretend you didn't see that. Okay, there we go. That'll work reasonably well. Looks like there's an issue with it not saving. Oh, this is not even in the right directory. Uh-oh. I'll fix this real quick. All right. Before anybody submits anything, it should now be actually responding the correct thing. No, I mean performance in terms of how quickly it would be able to find the optimal policy, Olivier. Or Olivier, I'm not quite sure. Why didn't this go into the right thing? All right. Somebody has already answered question 2 incorrectly. They should be letters, not numbers. Somebody else has also done question 2 incorrectly, but they've listed every single no that it would take to get between these things. That's not the answer. It should be a literal, it should look like a table, which is to say that each line of this answer should have 4 values. Unfortunately, what I really wanted was just to give you a table, but Google Forms wouldn't let me do that. It should literally be a 4x4 table. There we go. Somebody got it. Give you all another minute and let's go over these answers. I like how I said out loud, there should be four letters for each line for question 2, and people immediately ignored that. That's great. This person's put 2 letters for each line. All right. Yeah, I know. This would be easier if I could have had a literal table. Even then, I think people would have confusion, would have issues with it though. At least one person understood how to answer question 2. Okay, let's go ahead and stop. Yeah, well, this is why I had question 2 here. Okay, we'll do it this way. Okay, let's go over these questions real quick. There we go. For question 1, I'm just going to say it out loud because I'm no longer sharing my screen, right? I was asking you, what was the way that wouldn't increase the performance of MCTS? So the first one was that we would increase the number of rollouts. Would that improve MCTS performance? Some nods here. Correct, it would. So that's not the answer. Increasing the max depth. Would that increase the performance? Some nodding. Yes, that's correct. How about C, increasing the heuristic cost of each simulation step by 1? Some shaking their head. Right, and you already saw the answer was C, so you should know it was C. If anybody doesn't say C after seeing the answer, I don't know. Okay, 2 is going to be the issue. Actually, I should keep sharing my screen, because otherwise, how would you see? Yeah. All right, people who can't see that, you can at least look at the Google form, right? So what I was looking here, right, is for the nav table. The nav table, as a reminder from APSP, is a sense of from what node, what other node do I go to be able to get there? Okay, so that means that along this diagonal, it should just be the thing itself. So that we should have an A, a B, a C, and a D. Unless there was like negative values to it, at which point we would have to say like, okay, well then in fact, it's gonna be cheaper to go like around in a cycle to be able to get to this node. But in fact, there was no negative cycles. In fact, there were no negative numbers at all. So then from there, we can say, if I wanted to go from A, the row, to B, the column, what is the next node I should go to? Any suggestions? B, okay, that's interesting. So if we're gonna go from A to B, that would be a cost of 20, right? But if I go from A to C to B, that's a cost of 15. So actually, if I want to go from A to B, I want to go to C next. Does it make sense? Okay, some nodding. Good. I like to see the nodding. If I want to go to C, this one's obvious. I want to go to C, right? And then for going to D, right, we could say B, but that would be wrong because this is 25. Versus if we go to C to C, or C to B, from B to D, that's just 20. So that means that across this first line, the first answer should have just been A, C, 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 right? I'm not going to do the full thing because we only have a minute left, but this is the basic way that you'd solve this problem. Cool? Cool. Some nods. I like to see the nods. Okay, then the final question. Say we had 3 rules, blah, 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 blah. What would be set on iteration 0? Well, what we want to do is we want to check and see the heuristic that is the most specific rule that fires. The trick here is that rule 3 is the most specific rule on both iteration 0 and iteration 1. So rule 3 should have fired both times. Yeah. It has more conditions is what I should have written. I'll rewrite that now. Has the most conditions. But understandable why you would say like, most specific, I think means the most specific to the situation. For sure, that's completely understandable. Cool, that's it. I'm aware that we're at time. Thanks so much for your patience today. I know this was a wild and insane thing. But yeah, we made it through. I'd recommend if you're interested, go back and watch the rest of those videos that we didn't have time